And welcome back. We had a really good discussion with this group last time about sort of that philosophical safe system, and we were thinking pretty broadly about road safety, weren't we? And that was good. I enjoyed that discussion. Really great comments came in, some disrupting of people's thinking, some people challenging different things. It was really a good session. This session, we're going to hone in on the road infrastructure, the road environment, the road design. I've got a few little activities for you to do in this session. We are going to delve further into kinetic energy at intersections, kinetic energy thresholds, and we're going to have a good discussion about intersections and how we make them align highly with safe system principles or not. And we'll talk about mid-block locations as well. So that's between intersections. Of course, don't forget to count your wallies as we go. Right, let's have a look here. Intersections. They're a really interesting part of our network. And a lot of people focus on, obviously, the crash between vehicles at intersections. And that's certainly a source of death and serious injury to our community. And we see that happen at signalized intersections, at passively controlled intersections. And passively controlled, by that I mean a give way or a stop intersection, so a yield control or a stop control intersection. We certainly see these crashes happen. But one of the things a lot of people often are not aware of is that we actually have an increase in risk of run-off road crashes at intersections or around intersections. And that's for a number of reasons. One is that you introduce conflict or turbulence at this location due to a vehicle that may enter the intersection while another vehicle is approaching, and then you have vehicles avoiding, running off the road. You also have vehicles that hit and clip other vehicles and spin off and go into different directions. And if you analyze intersections, you see that we put fixed hazards around intersections. So it could be traffic signal poles, it could be power poles, because you often need to turn your power line, down to go down that side road. We put power poles. There's culverts for drainage, because obviously you've got two roads coming in and you need to drain through that. So we've got this, mix there of roadside hazards in an area that we have increased turbulence and increase of people leaving the road. So what you do is, if on a length of road you plot risk, and we do this with different methods, but if you've got risk, here, what you'll see is that along the road, the risk will sort of bubble along and then spike, bubble along and spike. Okay, and those spikes are the intersections. There is an inherent sort of existing risk, and then that spike due to the conflict points, the volume, and other characteristics. So if we have a look at the principles of intersection design, then this is from the Monash University Accident Research Centre, and I'll take you through that. I won't go in detail into this, and I don't like this many words on a slide, but if you remember at the end of last session, we talked about exposure to crashes, likelihood of crashes, and severity of crashes. That's going to be a big theme of what we are going to talk about in this session. Okay, how many people are exposed to this crash type? What is the likelihood of that crash occurring? And then how bad is it going to be? And if we look at these principles of intersection design, which Monash University put down, if we've got fewer vehicles or fewer intersections, I mean, practically these are very hard things to actually implement, but nonetheless, like, those influence the exposure to crashes. Or if you've somehow eliminated that conflict point, all of the conflict points, but I'll get to that. Because the next one is conflict points per intersection. That is actually a likelihood factor. If you haven't eliminated conflict points, all the conflict points, then we're into likelihood. Then we've got all of these severity factors. And those are, the angles and the speeds and thinking about our biomechanically tolerable levels. And you see there, 90 degrees is around that 50 kilometer per hour. If you can get a bit more angle on it, we can increase speed a bit. This is passenger vehicle to passenger vehicle. I need to take you back to your high school physics for this one, and vectors. Around the vectors. A crash like this has energy that's transferred into the environment. A crash like this has more energy transferred into the environment. So you kind of bounce off in those crash types. So that's an important sort of aspect to us thinking about energy management in these intersection crashes. If we have vulnerable road users, we're thinking around 30 kilometers per hour or below as the speeds that we want to be aiming at. And where we can't sort of achieve this, we've really got to start to think about altering the design of that intersection or that configuration altogether. Now, I think this is going to be easier if we get into some examples and I will take you through that. So here's a table that just has that. So passenger vehicle to passenger vehicle. I know some of you are very interested in pedestrians and cyclists and how they play out into this. And so I just want you to pause on that. Next session is all about pedestrians and cyclists and motorcyclists. I've got my colleague Max McCardle, who really specializes in that. He's going to come and give you some insights there. I'm just talking passenger vehicle to passenger vehicle at this stage. Really, most crashes, in fact, all crashes generally at around that 40 kilometer per hour passenger vehicle to passenger vehicle are within our tolerable ranges. And it sort of maxes out around that 50 for the 90 degree crash angle, 60 for that other angle, and then somewhere around the 70 for the head-on / rear end style crashes. There's a lot of debate out around rear end and where we should be placing that. It's got interesting sort of, vector physics around it, where you've got sort of, those sort of things going on around. But nonetheless, we're sort of saying somewhere around that 70 range. Now, yeah, people want to get very precise sometimes with this, and it's not a precise science. There are models such as ChemX, which is the kinetic energy management model, where you can be a bit more precise, but even that is, you've got so many variables in there, but we have these general speeds that we think of as thresholds. So when you get to an intersection, or you're given an intersection to look at, you can start to say, what are the angles that the crashes could occur at? Okay, and you don't need to be this precise. I mean, if you're working in CAD, you can be easily this precise, but the point of it around, a safe system assessor, we don't really need to do that. We can just sort of go, a vehicle exiting there and a vehicle coming through there, that's about the right angle. And so I'm thinking around there, the 50 kilometer per hour is sort of threshold speed. Over this side, they're coming out a bit and then being struck there. Okay, maybe that one's a bit higher, so we can go sort of thinking around the 60 kilometers per hour. But you can see how I'm going immediately from angles of crashes and speeds. And that's how I'm just at a very basic level thinking about energy and energy management and thresholds. Okay? And you'll be having to do this as a safe system assessor. You're having to be thinking, okay, that crash could happen. So what's the angle that they'll sort of crash at? And what vehicles will be involved? And what speeds under these threshold speeds are we thinking this might happen? We do think about that secondary crash impact. So the vehicle-to-vehicle collision, and then there will be sort of a resulting secondary collision, or as I mentioned before, the avoiding, the clipping of the front or the back of the vehicle is out of control vehicles because there's more turbulence at this intersection and a lot more going on. So we've got to think a little bit about that as well. The Centre for Automotive Safety Research out of the University of Adelaide did a big study on this. It's one of these ones where I go, do we need a big study to tell us this? It's probably pretty obvious, but nonetheless, they did the study. So they replotted a whole lot of intersection crashes onto these axes and then told us where the secondary crashes of death and serious injury were occurring. As you know, I think we would probably have guessed that, but nonetheless, there you go. It's there with some data and evidence around it. A few interesting sort of clip off ones and spinning off into other directions and strange things happening, but that's what we see. Okay, safe system intersection exercise. So I'm getting you into doing something pretty quickly, and I'm going to give you a few minutes. Well, I'm going to give you the introduction to this little exercise, and then you're going to have a little bit of time to think and to write down your answers. Here's our intersection. Okay, we've got an existing intersection. And I'm going to give you some info, some data around this intersection. Okay, it is a 70km/h road, the major arterial highway here, sort of on the outskirts of a big town, a big city, well, a city, sort of, yeah, it's a decent sized city. Okay, 70 km/h coming in there. It has about 22,000 vehicles a day. It's got heavy vehicles. It's got buses. This is a bus stop here. It's a bus stop. We've got a side road here which has a 50 km/h speed limit, and it's got somewhere around 2,500 vehicles a day, 2,500. What else can I tell you? This is a shared user path, like cyclists and pedestrians use that. This is a drain, like it's a big culvert, so it runs that way. This is a service road, vehicles going both directions in there, turn lane there, obviously. Residential area, you can see houses. That's a bit of sort of floodway, parkland. There's a crossing here, a bit of a refuge. There's a crossing here, which is what we call a Danish offset or a Z crossing. It happens to be the wrong way around, unless, yeah, well, it is the wrong way around. You configure these so you walk towards traffic, which is that way, as we drive, obviously drive on the left. Except for Mark, sorry, this is backwards for you, Mark. You configure them that way. This one's configured the wrong way. It's a minor little issue, but it's the kind of thing that makes the road safety auditor's eye twitch a little bit. But, you know, minor thing to pick up. Sorry, a little tangent I took. Let me jump you down to street level here. There you go. You can see the intersection. You can see that's the road that comes in there. There's a bus stop over there. You can see 2 lanes of traffic in each direction. Got some lighting. There you go. Here's it from the other direction. You can see there's that drain structure thing. It's a shared user path over there. There's a intersecting road there. So what your task is here, your task is to eliminate death and serious injury at this intersection into the future. We'll get us as close to elimination of death and serious injury as we can. I like this group, so I'm giving you an extra $1 million. You can have $4 million to do whatever you want, but you can't close the intersection. I know you're thinking back to that, ooh, to eliminate people getting into this intersection, which would eliminate exposure, which would eliminate passion. You can't do that because we've had some discussions with the residents. That's not acceptable. And then the third one here is that you're operating in your current political and organizational framework. So if you come up with something that's, you know, quite new, quite extreme or the like, I want a little bit of an idea of how you might navigate that through the system. So you can come up with whatever you want. And if you are somebody who doesn't, you know, have a clue what things are going to cost, which is fine. This is not an exercise about, you know, precision cost estimation. You just simply type in what you're thinking you might like to do, and I will be an instant cost estimator. And so I will tell you how much things cost. So what you're going to do is pop your ideas in, but the important, okay, so people are already doing it, but hold on, please don't type it in yet, because the most important thing I want you to do for everything that you put in, you need to tell me if you are influencing the exposure to crashes or the likelihood of crashes or the severity of crashes. So write in whatever you write in. So we're seeing somebody wants to signalize the intersection. Well, would signalizing the intersection change the exposure or the likelihood or the severity? And I'll tell you now, it will change the likelihood. So, okay, so if you want a cost, just put in whatever the treatment is and then cost question mark. And I see Nathan wants to know how much an overpass will cost. It will cost you $48 million to do a flyover with access ramps on. So well out of budget there. But happy to take any other cost estimations as we go. But the thing I really stress here, I need you to say if this is what you're proposing is going to address exposure, likelihood, or severity, or a combination, and you can break it down for any elements you have. I'm going to give you a good 3 or 4 minutes to do this, so have a think about it and pop your ideas, and then we'll have a good chat about it. Okay, so Mark's asking a bit of a clarification question. What is the adherence to the posted speed limit? So 85th percentile speed there is pretty close to the 70 kilometers per hour. So 85% of vehicles within that. And then there's a bit of a tail of people going a little bit faster than that. But so signals will cost $2.9 million. Speed reduction, just reducing the regulatory speed limit, we'll add another 50,000 on that for not just the signs and things, but we've got a sort of exercise to go through with reporting and consultation and changing our speed sign system so that the navigation systems and the like can pick up on that. Wow, okay. I'll give it a little bit more time, but only a minute. Wow. So Kez, this group is very good and they are very interactive.
Yeah, there's a lot coming through here. We'll keep up with it.
Yep. So raised pedestrian crossing depends. So Rosemary's asking a cost for that. It depends where you're talking about doing that. On the service roads, yeah, maybe in your 50K range. If you're trying to get that across the arterials, you're in up for a lot more than that, but still within budget. Okay. Does the bus turn up the side road? Not the bus that stops at that bus stop. There are some school buses that go up there. There's a school down the road here about 400 meters or something like that. Rumble strips before. Wow. Okay. I'm certainly not going to be able to talk to everybody's comments here, but I've been reading them as they come in, and I'm absolutely, well, there's a few things I'm liking lots of the ideas. I'm liking that people are having to go at this categorization, and that's really important, this categorization, exposure or likelihood or severity, because safe system assessors need to categorize as they think through stuff. And you'll see why that's so important when we get to the scoring, but it's so important that we understand what is influencing what in our risk equation here. Okay, so here we go. Let's have a look at what people thought. Okay, we had some people very quick out there onto the idea of signalizing this intersection. And then there was a bit of discussion about, okay, is that going to influence exposure or likelihood or severity? Now, that's a really good debate to have because it helps us clarify this exposure or likelihood or severity. If this was to be signalized, right? So traffic signals there, that influences the likelihood of crashes. Okay, and we only attribute it to likelihood of crashes. Why is that? Some people might be saying, but surely that's exposure and severity as well. But no, what we say is that certainly there's some people that will slow down but still crash, and there'll be a less severe crash. But we are concerned with the ones that go through just at the speed that they were going, and the angles are the same, and speed and angle, so the severity will be the same. And exposure, because that's the number of people, the same number of people are using this intersection. Okay, we might get slight alterations in volume when you do a little bit of modeling, and some people might use this intersection instead of others, but that's going to be some minor changes. The exposure is going to be the same because the same number of vehicles are going through this location. So it's just a reduction in the likelihood. And so some of you are onto that quite well. So then some people, I think, wanted to look at roundabouts. And I like that idea that people are looking at roundabouts. Nobody asked me the cost of a roundabout, and that becomes a very interesting one. The cost of a roundabout at this location is $7.9 million. It's outside the budget. And that's a roundabout to sort of conform with the Austroads Guide to Road Design Part 4B. And it's due to the fact that we need to get these large vehicles through this roundabout. And then we've got to move a whole lot of services here, and we've got to acquire some land, and the costs sort of build up quite quickly. But I like the fact people are looking at roundabouts because roundabouts are a severity reduction technique. And I'll talk about that a little bit more shortly. So then we've got people who are into a whole lot of different things, and we've got some general commentary around working with this drainage structure and maybe protecting the drainage structure with a barrier system, or protecting road users from hitting the drainage structure. So instead of running off the road here and landing in this culvert, you run off the road, hit a barrier, and run along the barrier. So that is a reduction in severity. Hitting that barrier is still a crash. It's going to be far less severe than landing in the in the drainage channel there. Okay, so now we're going to get on to, we're going to give Chantel a prize for the first one to suggest some vertical deflection. What do I mean by vertical deflection? So some sort of raising of the intersection to try to, lessen the severity of any incident that may occur. And I'll come back to that a little bit more later. Sorry, I'm just reading this as we go. So we've got, I'm going to read through and see if there's anything else that's sort of very different to what we've been saying. So some people tweaking around with the service roads to try to lessen the chance of a crash, and that's good. So make it a one-way or the like, and that would reduce the likelihood of crash. Is that our sort of biggest source of death and serious injury? Well, probably not, because there's not really the speeds there to warrant or to get over many of those thresholds, but I think it's something worth looking at. Removal of trees. So people want to remove some of these large trees. Now, this is an interesting one from is it exposure, is it likelihood, is it severity? So if we were to remove this tree, for example, it's a beautiful old tree, so I wouldn't like to remove it, but we can certainly talk about how this would play out. Would that remove exposure to crashes, likelihood of crashes, or severity of crashes? So in one sense, and one very isolated sort of scope boundary, we just put our scope around that. It changes the exposure to that crash. But we actually, as safe system assessors, think about runoff road crashes in general, and we're not eliminating the exposure to runoff road crashes, because if that's not there, the vehicle can still run off the road and still get in and hit other trees or houses or these sort of things. So removal of trees tends to sit actually within the likelihood and potentially severity. So you're changing sometimes from point source hazard crashes to point source being a tree or a power pole or the like, or to a more distributed crash type. Let me keep looking here. So raised platform with signalized, so Bob's onto another one there. So combining those two, Bob could have a prize for that. And I'm going to give just looking, I saw something pop up before that I wanted to have a look around. There it is. Vehicle crossing 4-lane intersection increases the risk of side impact crashes. Vehicles may, I guess, do the budget issues, the right turn from the minor road can be banned to reduce the exposure. Okay, so we couldn't really close the intersection, but there's people trying to look at, well, could we maybe make it left in, left out? And I think that's Elias put in a good one there. So a prize, it's not actually quite exposure, and that's why I wanted to talk to it. Well, again, it's a bit like that tree one. This is where we need to do a bit of refined thinking around exposure, likelihood, and severity. If we were to close off this turn, say, okay, you can only turn left out and left in. You want to go right, you go up there and you do a U-turn somewhere. So that actually would reduce the likelihood of crashes in our safe system assessment. So the reason why we say likelihood is there's less conflict point, right? But there's still the ability to have intersection crashes within this intersection. Any exposure reduction would only be due to less traffic volume, not the reduction in conflict points. So it's a little bit tricky, but think about it from a whole intersection. Have we eliminated the ability for intersection crashes to occur? No, we haven't. We've lessened the chance that they're going to happen because it's simpler, there's less conflict points. Yep, so another one which causes a little bit of confusion, and back to that idea of barrier systems. So it doesn't remove the exposure to that crash. It lessens the likelihood of crash, because that is, hitting that barrier is still considered a runoff road crash, just a very much a less severe runoff road crash. So comment in there around, well, a fence could be put down the middle to stop people crossing the road. Okay, that potentially would influence exposure to crashes. Not a fan of pedestrian fencing, because you often just see then people cross and then they walk up and they'll cross around there. So you may create danger, but in theory, if you had less people crossing, you have lessened the exposure, because less people exposed to this crash type. Okay. Badgerys come up with a good point around balanced volume flow for a roundabout. I think a prize there for immediately sort of showing some interesting sort of challenges we might face with a roundabout at this location. And Chantel's also put in lots of challenges and why it would cost so much. Okay, I'm going to use a few slides. Oh, hang on, there's something in the Q&A. Somebody's used that. That's the overpass one. Okay. Oh, hang on. I got one out of the box thinking here. This is the way. That's what we like. People disrupting our usual traffic engineering road design thinking. So Mark's popped in the idea of chicanes and slowing people using horizontal geometry on the approaches. So that's certainly a prize-worthy one there. Now, certainly in Australia, traditional traffic engineer and road designer wouldn't be thinking specifically of that, but we do need to disrupt our usual way of thinking around these sorts of areas. Let me take you through a few slides to talk to this, and we will have our break at some point soon. And I'm going to come back to a few things that were talked about by some others, because I certainly didn't get to everybody's comments there, but I have noted a few things. Okay, so we had people saying, right, traffic signals. We said traffic signals influence the likelihood of crashes. Hey, Kez, just out of interest, are you seeing a laughing emoji sitting on my screen?
Oh, I'm not at the moment, no.
No, it must be just stuck on my screen. There's a little in the corner. That's good. Okay. Signals are a likelihood reducing factor. They do a decent job of it too. I mean, they reduce the likelihood of crashes from a passively controlled intersection. So that's a give way, like yield or a stop sign, to signalizing that intersection. You see a reduction in crashes of around 45%. That's pretty good. And it's all by reducing the chance that that crash happens by giving these clear controls. But unfortunately, if you go and look at any sort of outer metropolitan area, and this pretty much works across the world, you see that, well, actually, I say across the world, not really in the Scandinavian countries, but most of the rest of the world, this seems to just play out that your outer metropolitan areas have concentrations of death and serious injury at large signalised intersections. So this is a little snip of heat mapping of death and serious injury, and this one happens to be out of metropolitan Melbourne. Signalised intersection, signalised intersection, signalised, 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 signalised. I mean, yes, the risk goes up because it's an intersection, these volumes are high. But the thing that is this sort of real challenge, the thing we need to address, is that these are somewhat seen as, well, we've done everything we can, because they have mast arms, they have LED signal lanterns, they've got red light cameras, that, you know, everybody's sort of thrown these at them and they just get ignored. And in fact, even worse than just getting ignored is that we go out and we build more of these and somehow expect we're going to get a different result. People run the red lights. Okay? We can do like all sorts of things to try to lessen the chance that happens. We can do advanced warning. We can do you know, more signal lanterns. We can do all sorts of things. People just continue to run the red light. When you put a big lumpy infrastructure in, like the roundabout, right, people sort of wake up from where they are, they slow down, and we have improved crash angles. I'll show you that in more detail shortly. But roundabouts, well, they address the severity of crash. Okay, some people want to say they reduce the likelihood of crash, and that's kind of intuitive to a degree because we have less conflict points, we have an easier, you know, decision to make. But there, you do get rear end crashes go up a little bit in terms of minor rear end crashes and some other little low severity bingles. But overall severity reduction, we get this huge benefit. And we know going from a passively controlled intersection, so yield, give way, stop sign, to a roundabout, we're in the above 80% reduction in crash, death and serious injuries there. So it's this huge reduction based on the severity. Now, I'm talking passenger vehicle to passenger vehicle crashes here. We will talk about pedestrians and cyclists at roundabouts in the next module. But why are they costing so much? Why did I say $7.9 million for that other one? Well, because it needed to be big. But you know, maybe some areas we can get away with small roundabouts. This is a very different road environment, but nonetheless, why would we get any road safety benefit out of this? Well, one of the big reasons we get road safety benefit out of something like this is disruption of priority. This is a really important aspect to think about. If this was just a give way control here, and that this road had priority, vehicles on this main road would be going at a certain speed. They would be fairly tuned out to the task that they are doing and wouldn't alter their driving behavior through the higher risk point. As soon as we alter this with the give way controls here in this roundabout, as these vehicles approach, they come back to it, they look around, they slow down, and we've just got this interconnectivity or the engagement with the driving task and the surrounding environment for the high risk spot. So this is sort of, this is the UK, and this is kind of the UK's equivalent of a North American four-way stop. And Australia really doesn't use a four-way stop, which is a shame. I mean, we really need to start disrupting the feeling of absolute priority because it becomes an unengaged driving task with speeds and angles that aren't good. If you're worried about the speeds and the like that people would go through these small roundabouts, you know, use of raised platforms on the approach to slow vehicles is a wonderful way to do things. You can, and Max will talk to you about this. You can connect pedestrian crossings over through there, and you know, make wonderful sort of environments. And Bob's made a good comment in there about you know, having pedestrian crossings near roundabouts, and Albert's made a good, or popped that question in there around that as well. And certainly I'm a big fan of that. I mean, let me jump back. Hopefully we don't pass any wallies. No, we didn't. Like, take an example like this. If you have unbalanced flow, right? So, maybe this leg over here is much less, or we've got a dominant leg. But also thinking about how you get pedestrians and cyclists across the road, you can kind of signalize a roundabout strategically and massively extend its life in terms of getting to vehicle saturation points, and also give that connectivity. So, for example, if we've got vehicles queuing back here, and it's an unbalanced flow, so we're just getting this continual flow through on this leg, so they're not getting the ability to go. I mean, you can put a nice set of signals there. You can often connect that, to a path facility on there. You've got a beautiful way for people to cross that's signalized. And then you can just put a traffic loop down here. So when vehicles start to queue over that, it goes, queue's getting too long, drops this to a stop, and vehicles there, they flush out. Yeah, they better give them a bit of storage space here, but they flush out, and then off we go again. And also, somebody can come up here, press the button, get across. So you can, it's called metering roundabouts. And you can meter roundabouts, get some really good extension of their life, provide some of those facilities. I'm a big fan of it. So just road safety engineering 101, in case you never got that or you'd forgotten it. Why are roundabouts better than traffic signals from a passenger vehicle to passenger vehicle perspective in road safety? Well, there are less conflict points. There are less spots that you can crash. So that's a good thing. There's your example. Each of those dots represents a specific conflict point, a way that you can crash. The angle of crash is much better. And remember, we were talking about angles of crashes, vectors. This is much better. Energy will be shot out to the environment, and this will be more into the vehicle. And this is that disruption of priority again. I mean, we know that people approach a set of traffic signals and they're half asleep. Some people, they're half asleep. Maybe they're a little bit intoxicated. Maybe they're thinking about the fight they've had with their partner. Maybe they're distracted by something else. These lists go on. Gee, I'd love everybody to be alert and compliant and have had a good night's sleep and a cup of coffee and are absolutely 100% focused on the driving task. But that is just absolute, utopia that doesn't exist with actual humans. And we need to start designing and thinking about people are not going to be fully aware of what they're doing in the driving task. And it's our role to acknowledge that within our design and our choices that we're making in terms of intersection form and control. Like a roundabout, this physical infrastructure in terms of horizontal alignment changes or even vertical alignment changes, something physical there, they come back to it. They wake up, they look around, they slow down, they're with us again for that point in time. Okay? And so it's a really wonderful, way to activate the interaction with the driving task and our road. Somebody said in the chat there that multi-lane roundabouts can be a bit of a challenge for a number of reasons in terms of also getting people across them and the like, but certainly interesting to analyze a bit. Roundabout design is fascinating, and I can go down a rabbit hole and be down there for many weeks and looking into all of that. I've been using of late a TMR Queensland tool that you plug in a huge amount of variables, and it starts to help you identify risk of roundabout design with all sorts of variables, which is fun. But Interesting data out around sort of speed vehicles go through roundabouts, single lane roundabouts, double lane roundabouts, and I chucked turbo roundabouts in there out of a bit of interest. So a turbo roundabout, for those who aren't familiar with it, well, that's a 2-lane roundabout, but we get safety performance out of these about the same as a 1-lane roundabout. Now, a turbo roundabout here has a raised separator on the approach and a raised separator within the circulating carriageway. So if you wanted to go right, you get yourself in the right lane and you sort of go in and out. It stops that straight lining and high speed through it, and it's part of those weaving conflicts and a few other things that we get. So, you know, I like the fact that people are like looking at this. These are a lot of ones out of the Netherlands and some of those countries who are thinking about that. Here's another turbo example, and I love this photo for a couple of reasons, this aerial image, but one of them especially is up here. We've got a truck that's entered into this intersection, so made some mistake. We've got this white band that's coming up here, and I look at this and I go, angle of crash. Oh, that's good. Like, that's not going to be severe, is it? Also speed, like we know just from the geometry of this intersection, that vehicle's going slow. An interesting, nice radial roundabout design, isn't it? As opposed to a sort of tangential, which we probably do in Australia, but that's a little bit too sort of specific. But that conflict is going to be safe. Whereas if we'd had a signalised intersection through here, and we'd had that vehicle make a mistake because they're obvious, you know, they've made a mistake, and come out, and we had that right angle, high speed, the severity would have been much, much worse. So this is one I sort of put in for two things. Bit of fun, I think. It's an amazing thing to see. But this is in the Netherlands, and we had a Dutch engineer we brought over to do lots of discussion around cyclists at roundabouts, and as I say, Max, next session is going to take you into some of that sort of stuff. But I popped this up, and I've never been to this one, but it's sort of fascinating to see. I said to the Dutch engineer, based on what we see there, speeds and volumes, I can't remember exactly what they were, but I was like, yeah, it'd probably be a large signalised intersection in Australia, operating at 2 sort of 80km/h roads or 70km/h roads, missignalised. And the Dutch engineer was just sort of bemused and said, well, hang on, how would you slow your vehicles? I said, no, it'd just be signalised. And he's like, but what about all the death and serious injury to your community? Like, how could you justify that? Like, how could you ethically do that? And I was like, it's just, yeah, it's a big problem. And the Dutch wouldn't even contemplate running that much energy through conflict points. It's insane in their mind. And this is far more logical, because you slow all the vehicles down, you have better angles of crashes, and yes, it's signalised as well, but you need to slow vehicles, and you need to make sure that everything's going slow. Now, I said, like somebody, I think Linda said in there, I'm like, wow, this would be just amazing. Like, where would you go and what, and they said, oh, no, at ground level, it's actually quite, logical. You don't see all of that. You just see where, your path and things like that. Anyway, but it's more that philosophy that the Dutch would rather do this, the massive land take and everything like that. Well, it's not rather do this. It's just inconceivable that you would have a high-speed, large signalised intersection. So it's nice to see that, for our more conventional ones in Australia and New Zealand and a lot of, the US and Canada and others operating these higher speed signalized intersections, that people are starting to challenge that and question it and say, well, what can we do to disrupt this feeling of ultimate priority and people sort of just running straight lines and having these harsh crashes? And here's a concept of a cut-through roundabout, which is the idea that you can get more capacity through this, because capacity constraints at roundabouts become a big thing. That a vehicle coming along here will be disrupted in their travel patterns and slow down and go around this. So these ideas are coming up. That one's not built as a concept, but I like the fact that people are now questioning just absolute run of the mill of, well, we'll just build a signalized intersection and maybe this one people will actually all follow the signal red light and stop, and of course they won't. And we just keep building them, and we keep having our community killed and seriously injured at them, and we build the next one and hope for something different as an outcome, and the same thing happens, and it's just this monotonous continuation of this inherently sort of deficient non-safe system aligned or low safe system aligned way of operating. So were the crash occurrences so high that something that complicated was necessary? So as I say, this hasn't been built, but the key is we need to slow vehicles through these conflict points, because you might say it's simple for it to be a large signalized intersection, but you saw they all have death and serious injury, even if they're simple. But it was interesting to see that quite a number of people were entertaining the idea of raising parts of that intersection that we were looking at as our case study. So people have sort of said, well, a roundabout's too expensive, we've got unbalanced flow, and traffic signals are probably our right way to go. Maybe thinking also about, pedestrians need to cross and cyclists, hard to get across roundabouts. And so all of that sort of goes into the melting pot of decision making. And then a lot of people were pretty quick at this, and they went signalization probably what would need to be happening. But then it's the requirement that we now have that next step to say, okay, we've landed on traffic signals, but how do we reduce the severity of the crashes? And you remember, we looked at exposure, likelihood, and severity, and you've got to look at how can we reduce the severity? And maybe either vertical deflection, or as Mark said, like horizontal deflection. Maybe we chicane people. Maybe we have these raised platforms. Reducing the speed limit is a good one as well, and I think that's sort of coming in. It's a little bit less effective than actual geometric changes, actual physical design of the road changes. They're so beneficial in terms of getting our actual compliance. And raised platforms on these areas, they're not like urban speed humps. They're not those harsh, but you adjust your ramp angles based on the speeds you're looking to get through. And so at that intersection, they sort of said, they did what many of you did. Mind you, it took them many months to do, and it took you only a few minutes, in terms of said, yeah, I think it's got to be signalized. But then they were smart enough, or they were, enough committed to sort of safe system thinking to say, you know what, we know that the signals down the road, we've got a crash problem. We know across our region, our 20 highest intersections for death and serious injury are all high-speed signalized intersections. Are we really just going to build another one and think we're going to get anything different? And they said, yeah, it's not acceptable. We got to do something else. We've got to try something different. And they said, what about these raised platforms? What about slowing vehicles on the approach? And why though would they only raise this bit and this bit and not the whole thing? Well, these are the bullet vehicles, aren't they? This vehicle going in and the vehicle coming out. I mean, they're target vehicles. They don't have enough speed to do the damage. You don't actually need to raise that whole area and spend that money, and you don't need to make it so a vehicle coming out here is disrupted in terms of their travel up and down. Doesn't work like that for a crossroad intersection, but the intersections certainly can work. And they thought about, well, what are the crash thresholds? And they were particularly thinking vehicle-to-vehicle crashes here, which was sort of their main risk concern. And they were thinking right-angle crashes where a vehicle shoots through here. And what speed we want to get that? 50 km/h or below. And so that's what they ended up building. And you can see it's raised, it's advisory at 50. 50 to try and get vehicles down to that threshold speed. There's another picture of it. And this one I took with a colleague while we were out there doing the post-opening road safety audit of this raised signalised intersection. And I particularly love this photo for the reason that the vehicle is slowing down at a green light, because that is an area of much higher risk. Now, my traffic operations friends and colleagues, ex-colleagues and the like, yeah, they got very angry at this photo. It's so inefficient. So, we're slowing everybody down at this point just for, the 1 in 500,000 chance that somebody's, running a red light and, pulled out there and all of these issues. It's inefficient. And I say, well, if we had been able to build a roundabout there, everybody would slow down and nobody would be complaining about it, because that is something we're all used to. This is just that this is a bit new. It's not something people are used to, that then we get all this pushback. So it becomes a really interesting way to alter the speeds at the intersection. So let me just check. I think I see a few things coming in here. Let me just talk to some of these. If the speed is reduced from 70 km/h in a roundabout, would still be a risk for vehicles to slow down on the main approach roundabout? No, so good question there. So a roundabout, like you don't need to put any speed limit reductions around a roundabout. The geometrics of how you design it will reduce vehicle speeds. You do good reverse curves on the approach to a roundabout, and you have an appropriately designed roundabout, there is no need for regulatory speed limit reductions. You will get vehicle speed down, no worries. Those posts don't look very frangible. Yes, okay, that's a very good point. Yes. What are your thoughts on non-standard pavement markings, raised platforms? Yeah, so they used yellow on this one just to try to not confuse it with a pedestrian crossing, which I don't think is, I don't think they were asking a bit too much of the public if they know that sort of yellow is a warning and white is a regulatory color and these sorts of things. And but in general, like, there's a whole lot of things people got concerned about. Not the color, but the reverse. Oh, so okay, so I see what you're saying. It's not actually, it's a very specific point. Albert can have a prize for being super eagle-eyed in the fact that actual setup is incorrect, but it's so very minor in its detail in terms of impact Yeah, there's a whole series, which something I want to address here. There's a whole series of concerns that people have with raised intersections that just do not actually play out when you implement them on these types of roads. And I can run through them very quickly. People say, you can't do this because heavy vehicles, all of their goods will be destroyed. Buses, you'll have all the passengers flung off the buses. People will hit this at speed and Dukes of Hazzard style fly off, into the houses and be killed. Drainage can't possibly work. The noise will be unbearable. Yeah, I can list them all, looking at drainage and this and that. If you actually put these in and you look at the actual evaluations of it, none of this plays out significantly. All that happens is people slow down, they navigate over it, and they continue on. And then we see great benefits coming out of it. So the fact is that this is new, a new way of looking at an area. And of course, we're going to get pushback from people. That's human nature. This is not how I've done it for the last 30 years, so it must be wrong. Well, I think we need to sort of progress along a bit in our thinking. But, I'm not particularly, I don't want to say that this particular treatment is the answer, but the thinking that goes into it to say, no, it is unacceptable that we leave severity on the table in that amount and solely rely on trying to reduce the chance that people will run the red light or the So the pedestrian crossing, well, I'll show you from up here, it's probably easier. So it just happens to be on this one, they only have pedestrian crossing there and there, which is kind of a common way to run a T intersection because you get better efficiency for vehicles entering and exiting, and you only need, one phase. It's not ideal, but it's just to answer that question. The other little thing I think is pretty cool, and I'll give you a break after this, is when you have a raised intersection, you see the dilemma zone reduce. So for those who aren't familiar with that term, the dilemma zone, it's a traffic engineering term, which is sort of defined as the point in time and space where a driver approaches a set of signals, they go orange, and they are in a dilemma. Do I put the foot down and go, or do I hit the brakes and stop? And the dilemma zone, as soon as you put that vertical deflection in, the dilemma zone just absolutely shrinks because the decision is almost made for them. They're going to stop. Okay. And so we get that wash off of the higher end, late orange into red runners. And it's a really wonderful sort of benefit in terms of dilemma zone reduction. So actually, I'll leave it on that picture. I'll come back to it. And it does remind me of a little example I want to give you, which I'm going to dig out of my archives while you have a 3-minute break, just a quick one, run, fill up your coffee, and we'll come back and get into it in 3 minutes. And I'll check the chat if anybody's got any questions that I've missed as well. So back in 3 minutes. A bit of discussion in the chat there around regulatory speed limit reductions around roundabouts. It's an interesting topic for discussion, and certainly jurisdictions around Australia do have different practices. Victoria, no requirement to do any regulatory speed limit reduction. New South Wales has some requirements. They will reduce speeds around it. Queensland doesn't, but they sometimes do that as a practice, as I think Chantel's popped in there. Sometimes they actually have speed limit reductions. And Albert giving an example of where there's been some of that around roundabouts and they're pretty much ignored, which is generally right. I mean, a speed limit reduction is going to be highly ineffective compared to a geometrically well-designed roundabout. And as I say, I don't think it's just the need for reverse curves and chicanes on the approach, but you can also do it with other methods, which actually I'll show you shortly, a different way of doing that. I want to tell you a little story, actually, which I was just sharing with another group who found it very interesting. So I'll share it with this group as well. And I have told it to people before, but I was working in a road authority for the Victorian government, so Vic Roads at the time, and I was in the road safety department, engineer in there doing lots of engineering-like things. And there was a massive congestion easing program that was deployed. It was called Keep Melbourne Moving, and it was all about trying to ease that congestion in those growth areas and those outer suburban areas. And this huge government investment, and the traffic engineers and network modelers, and they all analysed and looked, and they identified spots and projects. And a lot of the projects just happened to be removing roundabouts and replacing those roundabouts with sets of traffic signals, because they could manage the peaks flows better and get the modelling was showing that they got improvements during these peak hours and more vehicles through, and so that was a lot of these projects. And so our role in our department was to they'd come up with the projects and a bit of the design, and they'd send it in for a safety review, safety check by us. So we got these projects in, and it'd show, yep, so remove the roundabout, here's the signals. And what they were expecting us to do was check things like the signal phasing, the line marking was right, there was good sight lines to the signals, there were all of that sort of stuff. We've got appropriate tactile ground surface indicators and the like. But I kept a copy of a memo that we'd produce. We would do all of that, we'd check all of that, but this memo we produce and we put on the top as we sent it back. Now, hopefully, Kez, you're seeing that.
Yeah, you can see it.
Yeah, good. So the Road Safety Department has analysed this project as increasing crashes as follows. Project life, 20 years. Number of deaths attributed to this project, 2.3. We put a little people because, especially when you use decimal points, it sort of loses the fact that these are people. Serious injuries attributed to this project, 12.6. And yeah, so statement of acceptance. The above road trauma is accepted by, and plonk that on and sent it back. Now, like, these calculations are very easy to do. You use crash reduction factors, which are published publicly. There's a wonderful, it's called the Crash Modification Clearinghouse. It's housed in the US, it's worldwide, just collects information about how much the reduction in death and serious injury and other injury you'd expect from different treatments on the network, and you can work out your risk. So it's not a hard exercise to do. And yeah, you can imagine the response that this got, which was certainly not to sign it, but to be very angry that we were not considering all of the requirements and balancing and challenges that a road operator must consider and the like. But in the end, you sort of go, no, yeah, you sometimes have to boil it down to these things for people to start to take it seriously. And we didn't get any sign, but it certainly did create the cat amongst the pigeons for people to start rethinking it. We were told to stop doing it by our executive director, which is understandable from there, keeping things in check. But there was some work done that resulted in some changes, which I'll show you shortly. The fact is, nowadays you wouldn't need to be this inflammatory, and because a safe system assessment does essentially that and shows if we're actually going to increase the risk by doing something on the road network, it'll be pretty clear. It'll also tell you that existing bits of the road have major inherent risk associated with them, and that we should be trying to address those if funds are available, and you've got to think about strategically how do you address all of this existing risk that we have. But certainly, if we're going in and making fundamental changes, we can't increase the chance of death and serious injury. But safe system assessments now will do that job. So anyway, there you go. Nice little tangent story. Actually, and then this intersection, so this is the intersection of Dalton and Childs Road, was a roundabout. And actually in 15 years later, another congestion easing program, we still seem to be doing the same thing, trying to put more cars through some roads, which is, a bigger picture challenge. But anyway, it was a roundabout. It was being converted to traffic signals because the roundabout was, saturated and not performing in terms of traffic movement. And a safe system assessment was done during that process because that was mandatory. And the safe system assessment said, well, the speeds will be high through there. You'll have an increase in severity of crashes, and something should be done to reduce the speed. Either keep the roundabout and signalise it, or raise safety platforms through the intersection. And that's what they did. And this is not a small road. I think Dalton Road has 55,000 vehicles a day, so this road, and this has like 25,000 vehicles a day, Charles Road. And this is a major bus route, heavy vehicle route, emergency services route, and the three major intersections throughout here have raised safety platforms just so people slow down going through those conflict points. So there's an example of where the safe system assessment process has been implemented. It's starting to create wins, and we're seeing some good outcomes as a result. I saw something in the chat about free left turn lanes with zebra crossings versus signalised turns. So slip lanes and crossings is just an industry big debate at the moment. First and foremost, I'd say, and actually, as Albert said, that's correct line marking, in case people were wondering what we were talking about. The other one had line marking, which was more different and weird. The first thing I would say is that, we need slip lanes sometimes, literally just because you cannot fit a large vehicle to get around there. Like it just sometimes just can't, it doesn't work. So a lot of people will say, just remove the slip lane. I'm like, yeah, in some circumstances, that's the ultimate, and that's the best, but sometimes you just physically can't do it. So next I'd say raising is so important. Whatever control you go with, be it a zebra or a pedestrian crossing or a signalised, raising it is so important. I mean, a vehicle coming in here is looking out that way to see if they can go. They're not even looking at where the conflict could be coming from. So slowing it down is really important. And yeah, we did put out a safe system snippet on this with our preferred hierarchy of control, which actually aligns pretty well with the Queensland government's road safety policy, which has now been publicly released, but it's raised pedestrian crossing, as this is, removal of the slip lane if you can, raised pedestrian crossing, then raised signalised crossing. And the reason for that order, I think, was decided that pedestrians are going to cross regardless of whether the signals are operating for them or not. Some of them will. So you might as well, clarify priority for the bulk of the time. And then you're into, if it's not raised, signalised, and then this. So, yeah, but there's industry debate on that order. I would have liked that one to be at a lower speed, but anyway, it is what it is. So some of you are probably scratching your head at very much design specifics here. I know some of you are very technical people, and I love that. And so I'm going to just point you at, I'm not going to go through all of the technical detail around designing these things, because that's a massive thing to discuss. I'm going to point you at Road Design Note 0306 out of Vic Roads, or our DOT, which has some really good design information. But I'll also point you at this document, which is the effectiveness and implementation of raised safety platforms by Austroads. It's got an example there of the New Zealand one on the front, because they're doing quite a number of these. It's got lots of other examples. It goes into design specifics. It talks about ramp grades, how to think about drainage, how to think about large vehicles, how to integrate with your traffic signal controller loops and your SCAT systems and all sorts of stuff like that, which is, you know, the practical realities of detailing, designing these sort of things, which is good to have that intel. Okay, another one I just want to show you, and this again, this is not particularly about this specific treatment, but more about people's determination to address the severity of crashes. And this is an intersection that the region wanted to treat. It had sort of two minor roads, and then the arterial road sort of went around this way. High speed, all of this was 100 kilometers an hour. They did actually reduce it to 80 for safety concerns a while back, but it's still having a lot of trouble. And they said, well, we'd like to reduce the severity of crashes here, make this all safer. So let's build a roundabout. And they went, great. Then they got their roundabout designed and they did it. You know, reverse curves on the approach, big area with your roundabout, big reverse curves on the approach. And they're basically just massively having to take this land. That's a telecommunication exchange building. They had to move that. I think that was going to be $1 million in its own right to move, let alone the land take. And it just blew out. And they said, yeah, no, way out of what we, you know, can afford. And so they went, well, what about we just put some right turn lanes in? Well, sorry, going backwards. What about we just put some right turn lanes in? That'll, you know, reduce the likelihood of crashes, and we'll put some warning signs, and we'll sharpen up the line marking. And then it was sort of, this discussion came back as, you know, we're reducing the likelihood of crashes by a bit by doing it. You know, so if that's, you know, that's it. You know, it's not a bad thing to do, but could we do something about this severity? And that's where I love that they start to really say, no, what can we do? And they said, what about a smaller round and a straighter approach? But then they all got concerned about people's speed coming in and how fast are they going to be approaching. And again, they said, well, what about we just start to slow them down a little bit with some lighter vertical deflection, some lighter raised platforms. And they came up with this design, so sort of shallow raised platform and raising this a bit, straight approaches. So that's, you know, before it was horizontal deflection to slow people down on the approach. Now it's vertical deflection. And again, it's an interesting way to try to say, okay, we don't need to take as much land. They still need to buy some land. Don't need to move this beast. So that's going to be a good thing. And I think that this was under half the cost of the full-sized one. And so they find they did build, and you can see there the approach is sort of shallow, slowing down of people using a raised platform. And then you can see up here, we've got the raised area again, and then the roundabout. Now the roundabout's interesting because it's actually just a tiny little roundabout, and the rest of it is concrete apron. So large vehicles sort of sweep around and mount onto that area. They definitely sort of mount onto that area. But before I jump into the quiz, I mean, I think that, again, I don't want you to necessarily take, you know, too much out of the specifics of the treatment, but take out of the process that reduction in the severity of crashes is so important. And it's something we should absolutely strive for. And we might need to do things very differently to the way we've always been doing. So a colleague and I wrote the road design note guidance on compact roundabouts. We call these compact roundabouts. So happy to share that with you. I might have even already put it in the learning management system if you're thinking about designing these, because they get a bit tricky, like ramp grades, distance of ramps, your concrete apron. How do you do lighting? Because you can't put lights in the middle of it. All sorts of, different drainage and different challenges. So I'll point you at that as well if you're, again, a designer and you're interested in that. So do they consider a left-right stagger? So a staggered T? It's a good question there for Albert. So a staggered T, let me jump back here and just explain what we mean by that. So a staggered T, you'd probably go out there, you'd just like realign your road a bit and have vehicles that have to do that right, left. And what you get from that is that vehicles don't get a see-through effect. They don't overshoot. So it's generally a good treatment, but it is absolutely a likelihood reducing treatment. It's quite effective, but it's likelihood reducing. So unfortunately, when we stagger intersections, we still see vehicles less overshoot, more restart. So they come out, then they're struck. And the speeds through here on this road, still the same speed, still the same angle. So we're reducing the likelihood of crashes with staggering T's or staggering an intersection like that, but we're not doing anything for the severity of crashes again. But by all means, that's a good treatment to do. And that really reduces the likelihood of crashes. But I would love to see any possible way we can reduce the severity of that crash as well. Kez, I think we'll pop up a quiz. And it's only a one-question quiz, but it hopefully will help dispel a few things. So true or false? Traffic signals are not safe system. True, false, or unintelligible question, which means sort of Ken, your question doesn't really make any sense. So let's have people pop a few guesses in there. Remember, you're not marked on any of these. It's only after the sessions in the learning management system where you're actually marked. In fact, we don't even know who's answering what in this, so don't get too stressed. Okay, we'll give it 5 more seconds. 5, 4, 3, 2, 1. Let's end that poll. Let's have a look what people are saying. Oh, we've got a bit of a mix there. Most people saying false. A few for true and unintelligible question. Well, I mean, I think unintelligible question's probably a reasonable point to start because I haven't given you any context there. But I suppose false, absolutely, if you're thinking, well, it's not the traffic signals that are either safe system or not safe system. It's, how they are placed within a context. And maybe true if you had a particular context in mind of that high speed, traditional signalized intersection, then. But the other unintelligible thing about it is we don't tend to talk about things as a binary, it's safe system or it's not safe system. We talk about alignment with safe system principles and things that, better cater for people's mistakes and energy management and the like. But yeah, so a little bit of a trick there. But the reason I popped this up is I want to stress that some people have come out of this course and, said with the idea that, we can never install traffic signals again. They are not safe system. I'm like, no. You've missed my point. The point is around context, understanding the principles, acknowledging people are going to make mistakes, trying to design to minimize the severity of those mistakes. Thanks, Kez. Wouldn't left, right stagger have overlapping right turn lanes? Well, oh gosh, now I'm having to think. You do right left staggers. That's your oh gosh, this is now going to test me, isn't it? I haven't done a staggered intersection for a long time, but yeah, you do them that way. So you've got, still have your right turners can go in. Plus also, if you do it, stagger it the other way, the left turn, people queue over the through lane. Yeah, so if I draw one down here, the way you wouldn't want to do it, you have people come out and they sort of queue in this area, so they have to make a distinct decision at this point to go, and then they're free to continue. But here they'll get clogged up. And also, you're right, the turn lanes then just get in your way. So if you're doing it this way, you have to do it way down here in order to have your turn lane. Anyway, that's specifics. Okay, so Albert's pointing at some studies and the like, which is good. And just summary in your notes, you can look at in your own time, just summarizing what we talked about. So I want to talk about lane departures. And if we look at this bit of road, you don't know where it is, but it's a long, relatively straight bit of road. It's divided by a white line, two white lines. It's got a little bit of sealed shoulder. It's got some things in the roadside, some trees, some areas cleared. It's got, goes on and on and on, you know, hundreds of kilometers. Got the occasional little access point, occasional side road, carrying about 5,000 vehicles a day. So without knowing any more information, what types of crashes do you think we are seeing along this road? So pop it into the chat. We've seen a few already. And we're seeing, yep, that's right. You don't need to know much about this. You don't need to do in-depth crash investigations or crash studies of this road to know people will be leaving their lane and either head-on crashing or running off the road and hitting trees or hitting power poles or culverts. And that's right. And what we do know is that somewhere around that 5,000 vehicles per day is where we start to tick over to more head-on crashes than run-off road crashes. But regardless, we just know that people will leave their lane. They do it at high speed, and we see horrific outcomes. So dotted along this whole route is death and serious injury. And it's the same for all of these long, straight, relatively straight routes. We, you know, on curved routes, we also see this. Now, people sometimes get fixated on this little kink in the road. There's a little bit higher risk there, but there's significant risk here. And straights and curves, we see run-off road, we see head-on crashes, and we see just a horrendous amount of death and serious injury occurring on these sections. And again, like we can say, gee, we've got to stop people falling asleep, stop people leaving their lane, and we're going to do everything we can to make that happen. But unfortunately, they still do. And what we want to do is really understand how we can absolutely minimize the severity of crashes. Now, this is that ANCAP pole test we talked about in the last module, and the massive amount of energy being transferred there when people hit point source hazards. This is a pretty graphic crash. I mean, this is a real world, but I show this to show the amount of energy involved in crashes with point source hazards, trees, power poles. This is estimated at 60 kilometers per hour. It's a, let me just, the violence of this incident, like the amount of energy at a 60 it's unsurvivable. And we have these massive expanses of our road, just hundreds of thousands of kilometers of road where we have those speeds and higher, and point source hazards, and then the head-on risk and the risk of culverts and the risk of rollover in the roadsides. So the idea to clear the roadside of hazards is an attractive one, but you need to know the limitations. And if we look at crashes per 100 million vehicle kilometers traveled, we see that as you clear a roadside using a clear zone, and I'll tell you why we don't use clear zone anymore, but as we clear a road of hazards, you see that sort of death and serious injury reduces, and then it sort of asymptotes out, and you don't get below about 4 off-road casualty crashes per 100 million vehicle kilometers traveled. And that's because people roll over within cleared areas. So they're off the road, they're trying to get back on the road, they're going at high speed, they yaw, which is sort of sliding side to side, they roll. They also go beyond any cleared areas, they hit trees and power poles and culverts and the like. So we know that, you can get some good risk reduction in your very short area of the roadside, but it starts to lessen off after that. And the old way that we would look at creating a big road duplication project would be to create some sort of road like this, somewhat like this. It would have the big median, and you'd have your other carriageway over there, and you'd have this cleared area, and you'd have any trees and things outside of the calculated clear zone. And you probably wouldn't have these anything in there, it'd just be this cleared area. We see that sort of deployed. You also probably wouldn't have truck rumble strips. Oh no, am I leaving? You wouldn't have truck rumble strips, although they're not a bad thing to try if anybody's interested, because trucks don't get the audio warning through their cabin for normal audio tactile edgeline as well. So these are big trial, but interesting. Anyway, nonetheless, these roads have been built recently pretty much like this, and they're built, and then you'll see that people leave the road and hit the trees, they go across, they hit another vehicle. We've had them in Australia, within a few months of opening brand new billion-dollar sections of duplication, where a vehicle leaves the road, crosses the median, the wide cleared median that they've provided, hits another vehicle, families killed. And you just shake your head at how on earth can we build a billion-dollar piece of infrastructure and then within a short time there's death and serious injury. If it was a rail line and that happened, the thing would be closed until all of that risk was eliminated or put under so much risk reduction, risk management that it wouldn't occur again. Yet sort of practice would be to do that. The new Austroads Guide to Road Design Part 6, which is roadside design, safety and barriers, has progressed us along a significant way with the way we think about roadsides and medians and how to reduce risk. And if you are somebody who still uses clear zones and calculates clear zones, you want to stop doing that, because that's not part of what is done anymore. Part 6 does not talk about clear zones. If anything, it talks about NRRIT, which is Network Roadside Risk Intervention Thresholds. It's a bit of a process. You really need to get into it. We happen to do a 3-day or 3 or 2-day course on barrier design, and it really gets into the detail of that. That's a whole different kettle of fish. But what I want to try and just do is say where we want to go is continuous barrier systems. This is, some people call it the bumper bowling of roads, which I'm happy enough with that. But literally a barrier separating and a barrier on the roads. That is our highest alignment with safe system principles, because it acknowledges, hey, people, we're gonna put audio tactile edge line, we're gonna give them rest areas, we're gonna try and convince them all to have a good night's sleep, but some of them are still gonna drive tired, they're gonna drive distracted, they're gonna leave their lane, and gee, we want them hitting a barrier, not into another vehicle or into the roadside and hitting a tree or a culvert or a power pole or whatever it is. So that's the ultimate. And you can see there's a bit of a hierarchy of alignment with safe system principles, and it gets a bit challenging and complicated. The practical implementation of it and the choices of when you do it and where you can afford to do it and where you roll it out next, they're all valid things to think about. But I do find these things interesting, a little bit hard to see the detail here. But if you use an IRAP system or an OSRAP system, which star rates roads just the same as you star rate the energy rating on your fridge or your washing machine, or people do that, we can star rate roads for safety. That road with cleared area in the middle and roadside, which is, looks pretty good. It's a 4-star road, so it's got some good safety to it. But a 5-star road, barrier, barrier, barrier. And just look at your difference in land take as well. It's actually going to be cheaper in a lot of circumstances to build that. You won't have to buy farmers' land or clear all those trees or do all those other things. So there's some significant advantages there. Anyway, I've got lots of cross sections in your notes. You can have a look at there, what the star rating would be for them and the like. Of course, barrier design, you need to think in your specifics. You need to think of vehicles pulling over. You need to manage all of that. And there's the devil's often in the detail of how you do it. But at that high level philosophy, we want to protect road users when they make mistakes. We want to try and stop them making mistakes, but protect everybody when the mistake happens. Another interesting one here is again, I'm not going to hone in on the product itself, but I'm going to hone in on the way people have been thinking, which is a group of young males in an old Ford early in the morning on a weekend, crashed at some speed. So all sorts of common risk factors at play there. They hit a power pole, and the power pole had a Raptor cushion, which is a device that sits around the power pole. Now, it's not just like a football goalpost padding, like cushion. It actually rotates and sort of pushes energy away so it doesn't hit the point source hazard. And, miraculously, these people survive as crash around the sort of high 80 km/h impact speed, which is, in a car with, next to no safety features, a 1-star vehicle at the best. And at that speed, they should all be dead, or most of them are carrying lifelong debilitating injuries. But the miraculous sort of redirection of energy and some absorption of energy and the survival is pretty staggering. Really, it's just about, to me, people are continuing to more and more think about managing energy in crashes. And I think there's another good example, and There's many other ones out there that are starting to really hone in on that way of thinking. Okay, that's probably the last thing I wanted to show in this before I take you now through your exercise. But let's have a look in the chat, see if there's anything. Why would there be such a difference between a road and a rail line? Politics, better standards established for rail? It's a really interesting question. I mean, I think the freedom of access and the control, who's in control of it, and a few things. I think standards is a big one. It's a really complicated question. I don't know. Others might have some thoughts, some insights as well. Just finding our module here. Sorry, bear with me. 20. Okay.
There was just one more question from Sarah there about why we put barriers on both sides of the roads without leaving enough space for broken down cars to stop.
Yeah. Well, ideally you wouldn't. You'd have pullover areas and breakdown, but sometimes it's just this cost versus, the widening and the earthworks and the more rollout of barriers. It's one where I actually think sort of you need to be very careful how you do it, because in theory, rolling out barrier systems fairly close to the edge line has actually a much bigger saving to our community, because people leaving the road is a far bigger risk than people stop in a running lane being crashed with. But it's not, there is still a significant risk with people being stopped in a running lane or close to a running lane. So the public is absolutely not accepting of that if they break down and you leave them in a live lane environment. They're really irate, and I can understand why. So what we tend to do is have pullover brakes. So even if you're running your barrier at that point, at some point you widen it out. You give every kilometre or so, at least 500 metres or so, you have areas where they can pull over and they can get that break. It's a bit into the barrier design specifics. Okay, Kez, you can see the thing, hopefully?
Yes, I can see it.
What am I? Am I in student mode? I'm probably not. Let's switch me to student mode so people see what they see. Okay, here we go. Module 2, we're on. Into module 2. So PDF of the slides. What else we got in here? Effectiveness and implementation of road safety platforms. There's a webinar on that from Austroads, free. You can watch that. Road design on compact roundabouts. That's that one I told you about that I wrote with a colleague. So some good information on design specifics there. And there's a technical report on Surf Coast Kidman, which is the one we were just looking at as that example. But here we've got your quiz, which you're going to do, and you've already done one of those, so you know the deal there. But you've got the assignment to do. It's not going to take you long. You don't need to cancel your weekend plans because it's a very short exercise. So you're going to click on that. You've got 4 days and 4 hours to complete it. You should only need about 15 minutes, 10 minutes. It's a PDF. So you click on your PDF and the PDF, there it is. We open that up. And what we've got is an assignment, and you've got step 1, step 2, looks like a second step 2 somehow, and a step 3. That should be step 3 and 4, it doesn't matter. So we can follow the instructions. You select an intersection. It can be any intersection. It could be one that's outside your house or down the street, one you know of, you remember, you've got a concern with, or whatever it is. You fill out the info below. So here you put your name, and it's a fillable PDF. You put your name in there, and you put a link to the intersection, so Street View link or the coordinates of it, and you paste that in there. Okay, and then you inspect the intersection. If it's out the front of your house, you just can have a look at it, obviously, or But if you can do it on Street View, we're not too concerned. And then you fill out the information on table 2. I'll take you down. So this is it. And what we're interested in is you categorizing things correctly in exposure or likelihood or severity. So what are factors that might increase the exposure to crashes at this intersection? Influence or increase? What are the factors that could influence the likelihood of crashes? What are factors that could influence the severity of crashes? So you write either 1, 2, or 3 here, no more than 3. Dot points in there. And then you give us one thing that you could change that could reduce the exposure to crashes. One thing that could reduce the likelihood of crashes, one thing that could reduce the severity of crashes. Okay? So I've got a couple of minutes here. I'll take questions, but I'll just probably do one live to give everybody a little example. Yeah, I'll get back to that question. I'll just do this quick little example so people are clear. No, let's go with where we go is, let's jump into Sydney. I don't even know where I'm going to go. Okay, let's just randomly find ourselves an intersection. Oh, that looks good. Hip Street. I don't even know which suburb I'm in here, but this looks like a good intersection to have a look at. Oh, big signalised intersection. Bet there'd be death and serious injury here for sure. Okay, so what we'll do here is say, what is influencing the exposure to crashes? Well, the exposure to crashes is going to be the volume of traffic going through here, the number of pedestrians, the number of cyclists. So you could look at what's influencing it, or you could be a bit more simplistic and just say, traffic volume on major road. There you go. It's just, there's a few things that are influencing the exposure to crashes. Maybe you might be a bit more specific in your one, but that's, what we're sort of thinking about. What's influencing the likelihood of crashes? Well, interesting here. What do we got? We've got a pretty good surface. We've got some good lighting. We've got good pavement. We've got quite good line marking there. I'm going to go with something. Sorry, I'm just jumping back here. Yeah, we've got a straight alignment. We don't really have any signal mast arms and things like that. So I think people might run that red light. So I'm going to go with straight alignment. Straight alignment is 1. It could be anything. Surface, lighting. Is it got? It looks like. So I'm just going to jump a little closer. Yeah, is that his old incandescent globes? Yeah, that's not. So that's not going to be as bright as it could be. So that could be 1. Yeah, and then what's going to influence the severity? Well, it's going to be the speed of these vehicles, isn't it? So we got, the speed. You probably put in what the speed is, what the speed limit is, and maybe the operating speed. Right angle, crash potential. And then we go, well, what can we do to alter this, to influence? Well, and we're not cost constrained, so you could do, grade separation, flyover, or you could do, closed side road. There you go. You could do straight alignment, so we could do raised platform. So that was an interesting one. Actually, I'll take the raised platform out of there. I'll do raised platform here. Because you tend to say that a raised platform reduces the severity of crashes. The signals themselves are probably the ones that are influencing the likelihood of crashes. The speed limit reduction will influence the likelihood and severity of crashes. But you could do, you know, mast arms. You could do LED signal, whatever it is. Anyway, there you go. Assignment done. Submit. Maybe a little bit more detail, but you can see it doesn't take you too long, hopefully, to complete that assignment. So then you just save it locally, and then jump back in here, go to add submission, either drag and drop into there, or you can click on that, upload a file, choose the file, and find it, and off you go if you want. Save changes, and it's submitted, and that will be marked by somebody, and you'll get some feedback. Just if you haven't quite got your head around this exposure, likelihood, and severity. So do the quiz and do this little assignment, and that'll prime you up nicely for next session. Max will probably get somebody maybe live to talk through theirs and give out some prizes, and we can have a good chat on that. And you'll get some stuff on pedestrian cyclists and motorcyclists. So I'm just going to stop sharing there. I'm just going to check that I've covered everything. So somebody trying to view the video with the Mythbusters one, so Kez is working on that.
I've just checked, and that's been updated, so it should work now.
And Chantel's good. We have a lot of rural and remote corridors, which are hundreds of kilometers. Traffic volumes low, heavy vehicles, not feasible yet. The best way to increase the star rating on these roads is speed limit reductions, and it does have huge challenges and for us to roll out. I mean, you can do isolated treatments. This is a bigger picture, like this is a bigger topic. I mean, we've had a lot to talk about around this. You can do isolated treatments, but fundamentally speeds will need to be reduced on the roads we can't afford to put in the major infrastructure improvements. It's the only way we can sort of operate our system closer to a safe system. So sorry, I should have clarified that because I think it was a question. So in Austroad's guide, so Safe System Assessment Framework, they categorize treatments into, reducing likelihood, reducing severity. Raised platforms are a severity reduction technique. Signalizations are a likelihood reduction technique. So a raised signalized intersection is a likelihood and severity reduction technique. Hopefully that clarifies that. Great session, good interaction. Thank you very much, everybody. Of course, if you're struggling with your assignment, you want a bit of coaching, a little bit of a chat, get in contact. One of our people can certainly have that meeting with you. Maybe you've got a few attempts at it. Reach out if you're struggling to get access to the learning management system or having any troubles, just email through to that training at safesystemsolutions.com.au or email anybody's contact details you've got, and we'll help you out. Thanks, Kez.
Thanks, Ken.
Okay. Bye, everyone.
Bye.